Now let's start with the event. So I'm going to be explaining event.h first and then event.c, and this is how the sequence should be, because the header file can always be seen as an introduction or a summary for the C file. It explains all the types, the user-defined types, and the functions that will be written in event.c or the C file in general. Let's go over the event.h. Here it is. As you can see here, you will see data types that are explained. So here you have data types, and here you have data types, and here some function headers. We call this the function signature. Each and every line of those is considered a signature. What is a signature? It's the name of the function, the return type of the function, and the input parameter types of the function. That's why you will find it here written int, event type, int. There is no variable name. Okay, you don't need to put variable name, and you don't need, you can, but you don't need to. All right. The header file needs to be defined once and only once. And in order to do that, you need to define a directive for the compiler. What does it mean? It means what I'm going to be talking about now. See here, hash in C, this hash means a compiler directive. Whatever you see, whatever you find after this sign, all right, this is a message to the compiler. So you're telling the compiler here, if not diff. So if not defined. Who's not defined? I called it underscore event. So if you don't have a variable defined, and the name of that variable is underscore event, I'm saying here define it, underscore event. This if not diff has to be ended by end if. Do you see? And then between the if not diff, the define, and the end if, you write all the definition of the code that you want. Why do we do this? Because this header file can be called more than once. If it's called more than once and you don't do that, you will get a compiler error. Why? Because the compiler would think that you are defining the types more than once. You are defining those types more than once. So in order to make sure that whatever that is inside is defined once and only once, you do this directive. You say, if not diff underscore event. For the very first time, underscore event is not defined. So you're gonna define it and define everything else inside here until the end if. For the second time, when it's being called, it's gonna call if not diff event. No, it is defined. So you're gonna skip all the code after the end if, which means whatever that is inside the if not diff and end if is gonna be defined once and only once. So long story short, when you're writing a .h file, you have to start it with if not diff underscore event. Okay, it doesn't have to be underscore event, whatever variable you want, and then define that same exact variable, and then you end it with end if. And inside between the define and the end if, you write whatever you want to define. Now, the event is what you have seen in the process lifecycle. If you remember, we had here new state, we have the ready, correct? We have the running, we have the terminate, we have the waiting, correct? And you had here admission, right? You have here dispatch, you have exit, you have interrupt, you have IO request, and IO complete. All those arcs are the events, okay? I call them events. Also, they are the transitions, okay? So here, as you can see, we are defining an enum. I hope you remember that in C. In C, you have something called an enum, which is an enumerator. You basically give certain naming a value. Why? Would that help the user by any means? No. But it will make the readability of the code much easier. And instead of saying if the event is 1, you can say if the event is arrival. What is arrival? It's the admission, by the way. Okay, I called it here in the code arrival. Okay, the arrival is the admission. Here, IO request, instead of, IO complete, and so on. So you tell me, what is the value of the IO request 2? How did I know? That's how the enum works. If you don't give any initial number for the very first one, it's the default is 0. So it's going to be 0, 1, 2, and so on. If you give it an initial value, then which is 1 in this case, then the IO request is going to be 2, IO complete is going to be 3, time expire is going to be 4, interrupt is going to be 5, and so on. Okay? By the way, here, as you can see, I've defined time expire and interrupt. Why? Remember this transition, the interrupt transition, could be either event-based or time-based. So I called the time-based time expire, and I called the event-based the interrupt. All right, so what is this? This is an enum, and the name of the enum is event type. Event type. So basically the enum, this enum describes all those transitions that you can see here. All the transitions, all right? With a little bit different naming, okay, but I hope you can map this to that. And then now that we have defined the event type, now you can define the event itself. This is ANSI C, all right, standard C. So you cannot really define classes in C. You need C++. But the equivalent one, not really the equivalent, but what we use is what we call struct. Okay, how do you define the struct? Type definition, type def, struct, and then you give the struct a name. Okay, so I called it type def struct event. And then pay attention, event is capital A. And then you start with an opening a curly bracket and you close with a closing curly bracket, okay? Inside those two curly brackets, you can define the elements, the variables that build this type. I cannot stress on this enough. You are defining a type. I'm quite sure you know that from C, but this is just a reminder. So I'm saying the event here, I'm defining PID. What is PID? Process ID. Why would I put the process ID inside the event? I need to know that this event is occurring for this process. As an example, if you look at here, if you have an admission event, dispatch event, you need to say which process is getting dispatched. If you have an interrupt event, so you need to say which process is getting interrupted. You have IO request, so you need to say which process is requesting the IO. How would you say that? For me, I have included the PID inside the definition of the event. And then the event type. the event type, whether it is arrival, whether it is interrupt, time expire, exit, whatever that is. And the time when that interrupt happened. And the processor ID, in the case that we have more than one processor, or more than one CPU, you need to say this event is happening on CPU 0, this is happening on CPU 1, and so on. Not all events will need the processor ID, of course, right? All the output arcs will need it. See, the running state requires a CPU. So when you are doing an exit, when you are doing an input, an I/O request, when you are doing an interrupt, whether it's time-based or event-based, you need to say which processor ID. Because if you have more than one processor ID, you're going to be having more than one running state, right? This is for CPU 1, this is for CPU 2, this is for CPU 3, and so on. All right? So whatever arc that is going out from the running state, okay, whatever event going out from the running state, this will require the processor ID. So that's how we defined the event, struct event. You would tell me, why are you defining it as capital and why are you defining here as small? What is this? You can see this as a nickname. You know that from C, I hope, all right? This is a nickname. Instead of defining it as struct event, I don't want to write struct each and every time, so I give it a nickname. And we call it an alias. So I wrote it as event small. So, you know, when you want the event, you write it this way. As you can see here, in this function, it's returning event star. If you're going to be writing it in capital, then you have to write struct event capital star, okay? Now, what do you see here? You see the functions that you will write. The functions that are defined in the C code, in the .c file, okay? What do you see? You see a function called create event. What does it take? It takes an int, it takes an event type, it takes an int, and it takes an int. What are those? See, integer, event type, int, and int. So integer, event type, integer, integer. What does it return? It returns an pointer to event. Why pointer? So, you know, it's a kind of referencing the object. It's easier in C to deal with pointers than anything else. So here you have an int, event type, int, and int. What is those types? What do they represent? You will see them in the C code. Another function I wrote here called compare event. It basically takes two events to compare. Two events to compare. What is this void star? And what is this void star? Why is it void? Why isn't it event? You will see later when I talk about the code, okay? And it returns an integer. What is that integer? Look at that. The compare event returns one of three values. 0 if the two events are equal. 1 if the first one is greater than the second one. -1 if the first one is less than the second one. So see here, this void is number 1, this void is number 2. So if 1 and 2 are equal, this function will return 0. If the number 1 is greater than number 2, then it will return 1. If the first one is less than the second one, it will return -1. That's theoretical, of course, but you can always implement it as 0, positive, negative. You don't need to specify 1 and -1. Those are the three states. So if they're equal, you're going to be returning 0. If the first one is greater than the second one, you're going to be returning positive. It could be 1, it could be anything else. And if the first one is less than the second one, you're going to be returning negative, whether, 1 minus 1 or something else. You have something here called interpret event type. What does it mean, and why am I doing this? Do you see here the event type? We call it arrival, IO request, IO complete, and so on. However, if you print this, it's not going to print arrival or IO request. It's going to print 1. It's going to print 2, 3, 4, 5, and so on. You don't want it to print number. You want to print a word. So this function, okay, takes the event type and returns the word that explains it. So if you send 1, what is 1? Arrival. It will return the word arrival. If you send 3, which is IO complete, it will return the word IO complete or the phrase IO complete, and so on. Why am I doing this? To make it easier to print, okay? And here, print event, you send an event to be printed, all right? And copy event, you send 1 and 2. You get the contents of event 2, put it in event 1 to copy, okay? Why is it pointers? Call by reference, okay? If you don't know what call by reference is, please go back and study it, or you can come to me in the office hours to remind me what that is. So when you copy, what does it mean? You're going to getting the PID of the second one, put it in the PID of the first one. The type of the second one is going to be put in the first one. The time of the second one is going to be put in the first one, and the processor ID the same. By the way, as you can see here, this is int, event type, int, and int. Okay, when you create event, int, event type, int, and int. Okay, so what is this int? Is the processor, the process ID. What is this? This is the event type. What is the this int? It's the time. What is this int? It's the processor ID when you're creating an event. This is the explanation of the event.h, and now we're going to be seeing the event.c.